All right, so Unit 3, Module 5.4, Graphing Polynomials Functions, Day 1. We're actually going to work tomorrow on some Chromebooks and some exploratories, but I want to front load you with some vocabulary, so you need to understand some vocabulary. So standard form of polynomial is this funky looking equation, and I know it looks scary, but it really isn't. Any polynomial equation, I want to give you a quick example. The a values, it just says a sub n minus 1 because it's just telling the values of a are different. And the powers decrease. So what this is written is any polynomial function starts with numbers. So it could be 3x to the 4. Okay, and it can go, the powers of the x go down, so it could be plus 5x to the third minus 7x squared minus 2x minus 9. Or it could be a plus 9 at the end. All that equation up here means is that your a values can be all different. Sometimes they're the same, sometimes not. And that it starts with the highest power of x and it always decreases in the powers of x. So don't let this scare you. It's just kind of formality. This is just an example. The powers can start. You can skip powers. There's all kinds of things that can go on that we'll talk about later on. So turning points are points on the graph where the graph changes directions. So it's kind of where the graph makes a turn. It goes from either going up to going down or going down to going up. X-intercepts are where the graph crosses the x-axis. And then the other one is called in behavior. It's the trends in the y value of a function as the x value approaches positive and negative infinity. And I know that sounds really complicated, but all in all, if you look at the ends of the graph, we don't care what it does in the middle of the graph. We only care about the ends. So if we look at the ends of the graph, we're looking at what is the y value doing. So I kind of want to just give you a quick few examples of talking about in behavior. Notice, I didn't even put these on grids. I just kind of hand drew some functions. So here, this is, if I put in the axes, this is as x goes to positive infinity, because it's going to the left. So this says x goes to positive infinity, and that's how we'd write that. X with an arrow plus infinity. What's y value doing? Well, the y value is going to positive infinity as well, because the y value, as x moves this way, y is going up. But here, as x goes to negative infinity, so as x value moves to the left, the y value is still going up. So this is x goes to negative infinity, because it's going to the left. What's the y value doing? Well, it's still going to positive infinity. It still likes that positive. So likewise, if we look at this, this is the positive side, so as x is going positive, what's y doing? Well, it's going to negative. So as x goes to positive infinity, the y value is going to negative infinity. It's going down. And over here, as x goes to negative infinity, y is going to negative infinity. So this, and this, and this, and this, those are called end behaviors. What is the end of the graph doing? So here, as x is going positive, so as x goes to positive infinity, y is going to positive infinity. Here, as x goes to negative infinity, which means x is moving to the left, y is going to negative infinity. Now, they don't always do the same. This side, looking here, on this side, x is going to the negative infinity, but y is going to positive. And over here, x is going to positive infinity, and y is going down, so it's going to negative infinity. Okay, so end behavior just talks about what the graph is doing when x goes positive or x goes negative. So make sure you get these down. You're going to need this vocabulary for tomorrow, and we'll practice with some